This video is going to look at solubility rules. What we're looking at today is when you mix two different ions, do they form something that's soluble or insoluble? If they form something that's soluble, it'll make an aqueous, homogeneous solution. If you mix two different ions that do not dissolve in each other, we will get some type of precipitate. As you can see in the picture on the left, from a lab that you did earlier this year, physical and chemical changes, we saw that we formed a bright yellow precipitate, which is really just a solid within a solution. So if you could take a minute to open up to table F, that's really what we're going to be looking at for the main focus of this video. Table F is broken up into two charts, one that forms soluble compounds and one that forms insoluble compounds. On the left-hand chart, it says ions that form soluble compounds, and right next to that where it says exceptions, over here, these would be things that are insoluble. So right where I just circled in exceptions, if you could write the word insoluble, that would be good. The chart on the right are ions that form insoluble compounds. So then again, you could circle the word exceptions. And above exceptions on this one though, since the left side are insoluble, an exception over here you could write soluble. I'm just going to write S for now. But I want you to actually write soluble on your periodic table. So what we're going to do is we're going to look at a bunch of different compounds, and I'm going to show you how to use table F to figure out if the compound is soluble or not. When you get a compound, and what we're going to be doing with table F is they're going to give you ionic compounds so that we can break it up into ions. That's exactly what you're going to do, break it up into an ion. So here NaCl breaks up into an Na and a Cl ion. And you have to look for one of those ions as a category on the chart. So when we flip back to table F, okay, let's look at the next example, PbClO3. So we have to look on table E for either Pb or ClO3. So we're going to look on table E for either Pb or ClO3 in the category of ions. So just on the left-hand side, these are the ions that we're looking at. So I see I have ClO3 right here. ClO3 is soluble. There is nothing that you could put ClO3 with that will make it insoluble. So PbClO3 will also be soluble. Let's look down to the next one. NaClO4. Again, break it up into ions, Na and CrO4. Then we have to come to table F and we have to look for either Na. Oh, we see Na is right here. Na is always soluble. There's nothing you can put Na with that will make it insoluble. We also see we have CrO4 on this chart. CrO4 is insoluble, but if it's combined with group 1, Na is in group 1 of the periodic table, it's an exception. So instead of being insoluble, now it will be soluble. So that one, both ions appeared on the chart. So let's look at our last example, PbCrO4. We split it into the two ions that make it up, lead and chromate. We go back to table F, and we're going to look for either Pb or CrO4 to have one of the categories. So we come here and look at all the categories. There's no category for lead, but there is a category for chromate. Chromates are insoluble. So now we got to check, will Pb make it soluble? Well, Pb is not listed here as an exception, so that means that PbCrO4 is insoluble. So the answer to this example would be Pb CrO4 would be the one that's least soluble or insoluble. So we want to look at the following examples and determine if they're soluble or insoluble according to table F. The first one is AgCl. Just like we've been doing, you're going to split up the ionic compound into the ions that make it up. So here, Ag and Cl. You'll go to table F, and you're going to look for either Ag or Cl to have a category. As we look at table F, we see that chlorine has a category. It's under the halides, group 17, and the chlorides are generally soluble. The only way you can make a chloride insoluble is if it's with Ag or Pb or Hg, and since our compound is with Ag, we're going to say that our compound is insoluble. So in your chart for AgCl, to the right, I would write soluble in water. No. The next compound is calcium acetate. So Ca is calcium, and then C2H3O2 is acetate. You're going to go to table F, and you're going to look for either calcium or acetate to be one of the ions categories that you're looking at. So let's go back and look at table F. We see that acetate has its own category here, and there is nothing that will make acetate insoluble. So calcium acetate will be soluble in water. So when we go back and look at our notes, we could fill in soluble in water, yes. Okay, and the last example we're going to look at today is iron carbonate. We have to go to table F, and we have to look for either iron or carbonate to have a category. So as we look on the left hand side, I don't see a category over here for iron or carbonate. But I do notice there is a category for carbonate over here in this right hand side. Carbonate is in general insoluble. The only way you can make carbonate soluble is combining it with a group 1 or ammonium. Iron is not a group 1 or ammonium, so the compound will remain insoluble. So in your notes, fill in no for iron carbonate. And now what I would like you to do is I'd like you to try the last three on your own, and they're going to correspond with the last three questions of the Ed puzzle.